Okay. Um, Climate change is natural. It happens. And every now and then, weird stuff happens. Like at the end of the Paleocene. Uh, this is probably the best comparison we have with what's happening on Earth now, because there's a lot of differences, but there are some really striking similarities that we can learn um, from the peak temperature of about 56 million years ago. So we can see in the geological record that there was a huge burst of CO2 added to the earth for about 30 or 40,000 years. So there was like a period, 20 to 50,000 maximum, of extreme volcanic activity. We know where the volcanoes were because the type of rock leaves a signature of radioactive isotopes in the carbon. So we even know where the volcanoes were. Um, Kind of like the land bridge between, like the chain of islands between Alaska and Russia. Um, and that big surge of CO2 that we can measure in ice cores and in sediment deposits, that big surge of CO2 56 million years ago created a peak of temperature where temperatures climbed like now, and then they stayed really high for about 200,000 years. The planet was really hot, about 5 or 6 degrees hotter than average, maybe as much as 8 degrees hotter in a few parts of the planet. That's pretty extreme. We're only a couple degrees hotter now. And then, what's cool is because geology nerds, we can learn a lot. Like when it gets that hot, the ocean gets extremely acidic. You get more erosion because it's raining more. Ocean chemistry changes. Huge parts of the ocean went anaerobic, no oxygen. So this was the largest mass extinction event ever recorded in the oceans. Kind of a big whoop. Changed sea level. You had melting of permafrost and huge methane that kind of ran away with climate change after this. There was huge changes in the life on the planet. So this burst of volcanoes was one of the 5 previous mass extinctions. It was, I think, the most recent mass extinction was caused by volcanic activity. And there's some things that make this relevant. A, the mass extinction, holy crap, this is scary. B, the clear connection between CO2 and other variables. But here's where this is interesting. I said volcanic activity for 20 to 50,000 years, which means a whole bunch of CO2, but you might have to wait like 9 centuries before there's another eruption of that volcano, or another volcano pops up nearby and that one goes off, 20,000 years later or something. That CO2 surge was rapid by geological standards. So when you look at CO2 levels, it looked like a spike. But those CO2 levels are, stretched out over like 240 million years or whatever. So that spike is a pretty slow spike. Today, CO2 is being added to the atmosphere much, much, much faster. Like maybe 2,000 times faster. We're spiking CO2 so quickly. We are way bigger than the biggest volcano. We humans are digging up rocks from all over the earth and we're lighting them on fire all at once. So, interesting parallels, but one giant exception, we could hit 5 to 8 degrees Celsius in a few lifetimes, in a couple of centuries. That's a really fascinating difference. When temperature changes over 20,000 years, over 200,000 years, some things might be able to evolve in 200,000 years, right? Like there might be some individuals who can do okay on a hotter planet, and so they will change their range or change their behavior, right? So they'll have more babies and species will change over time. When temperature change is slow, it's not a big whoop. And when it's fast by geological records, that's a mass extinction. But you know, that also led to the rise of mammals. There's some opportunities. What about when climate change is really, really breakneck fast? That's what we're finding out now. That's number 26.